Hello everyone, in this session we will discuss the modeling steps of Data Vault and we'll design a quick model. The checklist we will talk in this session will be a guideline for us that we will extend and cover each point in further practices. So mainly the process of building a Data Vault has the following steps. The first step is setting the naming conventions. A naming convention is a common set of rules or guidelines to apply to the naming of tables and columns. I will provide the reference page for the naming convention so you can find in the attachments. And the second step is the modeling the hubs. This requires an understanding of the business keys and their usage across the business. So after establishing the business keys and hash keys, result of it we will create the hub tables. Then the next step is the modeling the links. It starts with establish the relationship between the business keys, hash keys, and hence the creation of the link tables. Then another step is the creation of the satellite tables. Satellites provide the context to each business keys, it means the hubs and as well as the link tables. Therefore, first we will regroup the satellites by rate of change and type of information and the source system. Then we will establish the description around the business keys, hash keys, and the result of it we will create the satellite tables. Then as a next step we will add standalone objects like calendars called descriptions as reference tables. And another step is to tune our model for query optimization, and if it is required, add the performance tables such as point in time and the bridge tables. And final step is the creation of the information mart. It means dimensional model or data marts for your reporting requirements. So last three steps are optional in here because it totally depends on your business needs and performance expectations on the system. And another critical point in here is as Data Vault supports incremental extension and development of model, you can start small with couple of tables to design your model and extend it with further tables iteratively. So now we will design a quick model with including steps we have learned so far. In example, we see an 3NF entity relational model that involves tables, gives information about a department in an organization, the employees work in there, and the projects they are enrolled. So we obviously see that we have three main entities in here: department, employee, and project, and all of them converted into physical tables. So when we look at the relationships, primary key of department table, which is department ID, is embedded into employee table as foreign key. So it shows in here there is a one-to-many relationship between department and employee. Because in a department, multiple employees can work, but an employee would only work in a single department at the same time. Then we have two additional tables that shows in which projects employees are work on. So it is clear that one employee can work in many projects, and a single project might be participated by multiple employees at the same time. So there is many-to-many relationship between employee and project. As you remember from earlier sessions, we handled many-to-many relationships in bridge tables. In here, works on table take the role of bridge table and store the primary key fields of employee and project tables. Okay, now we have an understanding our source tables that is based on 3NF model from our operational system, and we will build a data warehouse with Data Vault approach on top of it. According to our guideline, after defining the naming conventions, we will first model the hubs. So we already know that we have three main entities in here: department, project, and employee. But please keep in mind, works on table does not represent an entity in here. It is a relationship table that is meant to solve many-to-many cardinalities. Okay, we will first identify the business key fields for these entities. To short recap, a business key is something that the business uses to track, locate, and identify information, and there are multiple strategies that helps to identify the business keys. We may look at the database and see if the table has a unique index, and if there were no unique indexes, we would have to talk to business and also query the data directly to find the unique sets of columns. Let's suppose that we proceed this step and identify the business key fields as department ID, employee and project ID. And this information already identifies to our hub tables. We have 3 hub tables for department, employee and project, and include the business key columns which we identified from the source tables. And it includes the hash key columns as well, which is created by hash key generator based on the business keys. And we have standard columns that took place in each table as record source that shows the origin of the source system, and data load column that shows when the data is loaded into the tables. So when we back to the guideline, the next step is identifying the link tables. Link tables join the hub to another hub. So it's representing the relationships, transactions and hierarchies between them. And mostly primary key, foreign key relationship is an indication for that. So we clearly see that there is a relationship is established between the department and employee over the department ID and employee ID, primary key, foreign key columns. And it indicates us the first relationship. And another relationship is between the employee and project. So bridge tables are not entities, therefore they do not have their own business keys, which has a meaning to business. Therefore they only store the relationship between the entities. Therefore it indicates the second relationship for us. So we mainly identified the 2 relationships and hence the 2 link tables. The first link table is between the department and employee, and the second one is between the employee and project. Both link tables store the hash key columns from the hub tables and also create its own hash key value based on the business key fields from the relevant hubs. Then it also has standard record source and load date columns as similar to entire tables in Data Vault. Please keep in mind in here there is one-to-many relationship between department and employee. So department could have multiple employees and employee can only work in a single department. So for any reason, if this rule changes in future, according to new business model of an organization, that will be possible as the employee can work for more than department, for example, at the same time. Just think that employees assigned 50% to security department and 50% to administration. Then you see that in here the business rule is changed in the organization. So earlier we have one-to-many relationship, but now our relationship is turned to many-to-many. But thanks to link tables, we don't have to take care of this change because link tables already include many-to-many relationship. So even the business rule change, it will continue to work as it is. And according to our guideline, the next step is the modeling of satellites. Satellites provide the descriptive information of hub and link tables. So when we look at the source table, the attributes as name of employee, birthday, address, or department name or code, they're all descriptive definitions of the business key. And they need to be addressed to the satellite tables. We mentioned that we could create satellite for link and hub tables, but in this scenario, there is not any descriptive elements for relationship, hence the link tables. Therefore, we only create satellite tables for hubs and link to relevant hub table. But before creation of satellite, we know that mostly it is suggested to split the data among different satellites by source, data type, and rate of change. First, it is recommended to split the raw data by source system, but in this example, we suppose that we use the same source system for all tables, so we can skip this point. Then if the tables are big, we can further split it by frequency of change. For example, if we look at the employee table, the address of employee will change more than name of the employee. Most likely the name of employee will never change. Then we don't need to keep these attributes together in the same table, so we can split them to separate satellite tables. So address and city in the same satellite, and the rest of the information will be collected in the employee satellite. So for rest of the attributes for department and project, as we assume that don't have two big source tables, we can just keep each of them in a single satellite and connect to relevant hub tables. So for each satellite again, we have a mandatory fields as load date, record source and attributes. Then we have hash key column, but differently from hub and link, satellite does not have its own hash key. This field contains the hash key of the parent table. Here, a parent table can be a hub or a link depending on where a satellite will be attached to. So in employee satellite, it borrows the hash key from parent employee hub table. But the load date play a critical role in here because satellite tracks the history in the system by capturing all the changes happening in the descriptive data. Therefore, hash key values from parent tables does not uniquely identify each row in the table. For this reason, primary key of the satellite is the two part of the key, consisting hash key of the parent hub or link combined with the load date timestamp. Okay, now we designed our first Data Vault model from scratch and covered the first modeling steps that we have learned so far. But we will discuss another steps in the further practices. Thank you for your time.